Okay, so here today you're going to hear about the concept of data engineering, okay? And the question we can ask ourselves, is why do we care so much about data? And I just pulled out that little Dilbert strip, which basically, it's a comic strip, but it probably represents the reality a lot of what we are experiencing in many situations, because data quality is not an easy topic. And that's the reason we are here. That's what unites us in terms of either software vendor, users, and partners. So today, all we have to do is pretend, okay, for one day that data quality will matter, okay? And then we can decide at the end of the day whether that sticks or not. So I need to go back to last year a little bit for those who were not here, because we have been evolving. I mean, we have been going through themes like shaping data for action and trusting data for action. And then we went last year to conditioning data for digital transformation. And of course, digital transformation is what everybody uses nowadays, so we had to change that. And but conditioning data was the evolution of our thought process, that the reason you use Sigmafine traditionally was to create mass balance or create reports that people would use. The new reason for using Sigmafines, which we introduced last year, were more performance-oriented. You're trying now to apply the same kind of techniques to a different problem or to answer a different question. And the fundamentals of conditioning is that you're basically always conditioning for a purpose. You're always conditioning for a purpose. And, we need to condition the room, the temperature of the air in the room here. You need to condition your skin to look great. So last year, that's what we introduced. You need to condition data. You need to condition crude in order to put in the crude column. The same thing applies to data. We need to condition our data to make it usable for its end purpose. So data reconciliation, data validation, they're just methods. And so far, we've used the methods to do mass balance to help us, do some things. But the situations have evolved. And last year, we introduced conditioning data. And probably the most famous slide that every one of you has seen is that this is the before and after slide. So if you don't condition your data, you get what's happening on the left-hand side, no correlation. If you condition your data, the same data, nothing's changed, no data cleansing, nothing, just applying basic Sigmafine, you get something that's usable. I mean, that's kind of the whole story of using Sigmafine for data conditioning in one slide. So now this year we are evolving towards data engineering. Okay, and data engineering is something different. Okay, it's kind of what needs to happen behind data conditioning. So data engineering is basically putting a name on the work we do. It's not putting a name on what Sigmafine does, it's putting a name on the work we do. And I had to come up with a definition for data engineering. Data engineering, the way I define it, it's all the aspects of what we do in Sigmafine, which is collecting, validating, reconciling, organizing data and everything. So it includes that, because that's sort of the basics of data engineering. But it's also implementing this as a practice, okay, that you can run at the enterprise level. It's not something that is running in a computer in a corner of an office somewhere. It's something that is running at the enterprise level and that everybody can benefit from. And its purpose is to deliver sustainable data quality, trustable data, call it whatever you want. It's to deliver good data to the people who need it. And the people or the systems who need it is users, business process, data scientists, other applications, financial people. So there's a huge diversity. There's a very diversified crowd of people who consume Sigmafine data. If you go back to the P66 presentation of 2014, I think they were just listing, one after the other, all the people who are using Sigmafine data daily in their plant. So that's a very important aspect of data engineering. We are responsible to deliver that information. And then we have to be able to adapt. That's the new thing, is we have to be able now to go back and change our model. I think model building was number 5 on the list, because that's something we used to build a model and just let it there. It would do its job for 1 year, 2 years. Now we have to go back and change models and add things and remove things and adapt to what's changing in the plant. So that part of the work you do with Sigmafine, that's what we call data engineering. It's a summation of all these tasks that you have to do to bring data into a position where people can use it and make money, make decisions, do whatever they have to do in their job. It's sort of a behind-the-scene role, but it's a super important one. And the more we go into digital transformation, the more people realize how important it is, because you can't go into digital transformation or advanced analytics without doing this kind of basic work. And that's kind of, what's happening in the market right now. Okay, there's a lot of demand for digital assets and digital twins and digital this and digital that, but where do they come from? All these digital assets have to be prepared, generated, and data engineering is how we generate these data assets. That's how we, if we're able to deliver a data set that is usable, which I consider that to be a digital asset, that's our job. We've done our job. We've delivered something that is of quality that people can use inside the organization. And that's actually, in the marketplace, it's actually being identified, by IBM and other, HR analysts as the Quant Crunch. And you see the position of data scientist and data engineer. This is probably one of the most disrupting job right now in all the industries. Every company is adding this kind of staff and capability to their company. And furthermore, in the United States, this is part of the top 10 fastest growing jobs you have in technology, and it's part of the top 25 job career opportunities available in the market right now. So it's very significant. It's not, it's not like Sigmafine of 1993 where you just go into a refinery and just do some calculations. Using Sigmafine right now has become a weapon to create that or contribute to that digital transformation. And there's a person, when I was doing the research for this, I was kind of coming across a lot of information. There's one person that I retained her quote. She's not a celebrity, she's just another data person like us. But she said something which I believe is very important, is that by doing this job, we are holding the gateway to innovation. It's very difficult to improve anything in a plant if you don't have the information to work with. Otherwise, you're working in a vacuum, okay? In the process industries, we don't see anything. Everything's inside a pipe, a tank, so we have to rely on this sensors and information to do our job. So that part also means that we can't do this in a vacuum. We have to work with other people. We have to work with the consumers of that data to be able to understand what they need and deliver things in the right way. So we also have to work with the people who are managing the sensors and the meters and understand their challenge as well. So it's really a team effort, this data engineering thing. And before I go back to on topic with Sigmafine, I just want to leave you, for those who are interested by this topic, there's some people who have been saying this for years, and those of you may know them. The Datadoc has been in the HBR magazine a few times. He just had a series recently about the data quality issues associated with machine learning, how it's impacting machine learning negatively if you don't manage data quality. Dan Myers, Dan is trying to build a model whereby you can evaluate quantitatively or semi-quantitatively the quality of your data across all verticals. So he's including manufacturing as well in this domain. So he's a very brave man to undertake that. I spent a few hours with him and some of the team. It's not obvious to do that in a way that everybody will agree. And then IQ International is just an association, not so well known, but they're dedicated to data quality. So those are good resources if this is a topic of interest to you. So let's get back on our Sigmafine story. So what's the point? One of the questions that I come across most often is that everybody seems to own the solution to data quality. Okay, everywhere you go, they make you a pitch or they sell you a software, I'm going to take care of your data quality. In fact, it's a much more complex situation than this. I don't think anyone is owning the ultimate solution. The ultimate solution is a blend of things. And the reason why it's a blend is because data goes through phases while it's being collected. First of all, it's coming from the sensor. Some sensors are intelligent, they're able to do a good job. And it arrives at a certain point, in a database and a plant historian like the OSI SoftPy. And we have some options, and that's what we'll look at in a few minutes, to do some things. And at the outcome of that is the best we can do in terms of cleaning data, which I call cleansed data for lack of a better word. Our objective at that phase is just to minimize defects. Pretty much, we don't know what people are going to use data for. All we can do is minimize defects. That's all we can do, because we have no knowledge of the objective function or the outcome of the purpose that people want to use that data for. Then comes into the second phase, which we introduced last year, and I just recalled a few minutes ago, the conditioning. The conditioning is the aspect of quality that is tied to fitness of use. Okay, so a good quality product is not only a product without defect, it's a product that is usable. So it's both. So the story for data quality is that it's not one thing that you can do. It's a series of things that you need to put together to achieve the desired data quality outcome. And that's what we'll look at. If I can get the clicker to cooperate. Yes. Okay. So these are phases that we just discussed. So first thing we need to realize is that the first phase, we're working on data elements. We're not working on a data set. We're working fundamentally on every measurement that is coming in, working very hard to get it right. And we have some tools that we can use, like real-time data validation. We're going to check if it's not an I/O timeout, if it's not outside of range, or a value that we have all these basic tools that sometimes are built into control system, sometimes they're built into the PI system, and sometimes people get very clever and they develop very nice tactics, to capture this. Then we have other more advanced capabilities, which would be real-time, cross-validation. So if you want to do some pressure, temperature compensation on the run, you can do that because it's easy, because you have an equation, you run it, and it's not going to consume a lot of resources. You can do a bunch of aggregations on the run as well, just to transform the data into the way that's going to be more usable. You can do some filtration. So there's a lot has been written about all these things, but to me, that's our toolbox. That's our toolbox to actually work on the data and continuously find ways to improve it and get to a point where we've done the best job we can to clean up the data. At that point, there is nothing more we can do, because there is no other means to achieve a higher level of quality than to go to the second phase, which is to go with a Sigmafine approach, which is model-based. Now we're using the fact that there is redundancy between this information, and there's sufficient redundancy that we can leverage it to actually reduce the variance. So you all know that because you're using Sigmafine every day. But essentially, you go from cleansed data to either reconciled or validated data if you're working in a mass balance environment. But if you're working in a digital transformation environment, the goal is to get a data set out there to that machine learning or AI or advanced analytics that's running, which is the best possible data to do. So you, again, reduce the variance. And you can only do this by using model-based data reconciliation in the end of on your data. And so when you look at that, it's really, nobody has the real answer. We can say we're going to take care of your data quality, but that's not true. It's really a teamwork, and it has to be a participation of the customer, because data quality ultimately is defined by what we want to do with the data. It's not defined by just the data is right or wrong. It doesn't exist. Okay, it's defined by what we want to do in the data, and that's something that needs to come from the business. Just before we end this. Data quality, so just looking back in time, it's been an avoidance game, essentially, for all of us. We're just working at it by ourselves, alone, somewhere in a company. And it's like playing this Atari game where, you'll never win, okay? Because it's always coming at you and there's nothing you can do. Defects will continue to come. Meters are never going to be perfect sensors. So that used to be our mission, okay? And why we do this is because we want to avoid the economic downside of poor data. It's a battle, it's a fight, okay, essentially. Now, I think we have to do like the automobile industry. We have to get more clever. If we want less collision, we have to put some collision avoidance system. So it's the same concept for us. I think what we have to do is we have to improve our measurement systems. You'll hear about that today. We have to augment the information redundancy. We're having these conversations all the time. People want to know what's happening here. Well, he can't tell because you don't have enough information redundancy, so you need to expand the envelope a little bit more. Okay, it's more work, but you get a lot of value out of that work. We need to have good data management practices, and our managers or our directors or executives have to understand that this data engineering work is essential to the success of the rest. It's not an expense. It's an investment that we are making. We have to build detection systems, so we have to get more clever into how we implement Sigmafine. Automate the task. You've seen some of that happening in Sigmafine over the last couple of years, okay? Take all the intelligence we know about the data whether it's in the form of an equation, a table, or whatever, and just build it in. Just take all the operational knowledge we have in a particular facility and just put it in the model, put it to work. If it doesn't work perfectly the first time, it will work a little bit better the next time. But if we don't put it in, we'll never get to that kind of analogy of having a sort of data defects avoidance system, okay, which is where we want to be. I mean, we don't want to be fighting just every single data point, going bad on us all the time. We want to have a system. We want to use computers, technology, everything we can. So this is really the transformation that's happening, in the Sigmafine world right now in terms of going from very basic, data quality discussions to much more advanced and I don't want to say self-healing, but self-helping itself kind of approach where you can deal with the fact that you're missing a meter because the system knows has enough redundancy. He'll pick up, a value, and he'll tell you the meter is off, and he'll tell you go fix it. In the meantime, I'm giving you a replacement value. So this is very important. This is the story of where we are today with Sigmafine. So as a conclusion, the only goal of data engineering for me is data quality. That's data quality defined as we defined it here, which is minimize the defects and maximize the usability for whoever wants to use it. That's the definition of data quality. Sustaining data quality is a process and a team effort. Nobody has the full answer. It's impossible because we're spanning, that piece of data is coming off a sensor and is traveling in time through systems, and it gets touched and transformed, so nobody can claim to have the full control on that piece of data. It's not like picking up Twitter feeds, and running some AI on that, because you have one source of data. It's not that. Our data gets transformed and transported, in many different ways before it reaches the end. And the hope is the following, is that, in data quality, we have a double reward. If we do a good job of preventing bad data, we prevent losses. If we do a good job of getting data properly conditioned for the business, we also win. So it's a double win when you are doing a data quality approach like this. So thank you very much, and I hope you find through the stories of our customers today that they resonate in the same way to you as they are to us at PIMSOF. Thank you.